how to find the area of a parallelogram, and therefore a rhombus. There are two objectives, two things you need to be able to do by the end of the lesson. Number one, you will be able to explain how any parallelogram can be converted into a rectangle and why converting is important. Number two, you will be able to find the area of any parallelogram. And every rhombus is a parallelogram, so you will know how to find the area of those two. But in order to talk about parallelograms and their area, we have to take a quick step back, and we need to talk about how to find the area of a rectangle. You find the area of the rectangle by either doing length times width, which equals area in units squared, or you can call it base times height, which also equals the area in units squared. And when we're talking about length and width, length is usually the longer side, width the shorter. And when we talk about base, the base is usually the side on the bottom, and the height is the side that is going vertically. Base usually is horizontal, height vertical. Now, I'm going to blow your mind a little bit here. The formula for the area of a parallelogram is exactly the same. It's exactly the same as the formula for finding a rectangle. It is base times height. That equals area, again, in units squared. Is your mind blown? Now, you may be thinking to yourself, so what? Say what? How can something that looks like this have the exact same formula as something that looks like this? That doesn't make any sense. Well, let me show you. The reason that it works is that any parallelogram can become a rectangle. Let me say that again. Any parallelogram can become a rectangle. Let me show you how. Here we have a pretty normal parallelogram. I'm going to just take a piece off of the one side and watch what happens when I bring it over and reattach it on the other side. Boom, a rectangle. Let's watch that again. Parallelogram. Boom, rectangle. So any parallelogram can become a rectangle. Let's take a look at another one. Here's one of those funky ones that's kind of standing on end. Watch what I can do. Boom, rectangle. Oh, you want to see me go the other way? Boom, rectangle. So once again, the point I'm trying to make here is that any parallelogram can become a rectangle. And that is how they can both have base times height equals area in units squared as their formula. Now, there are some things that you need to know about doing this. When we're doing this, we are going to be using a base and a height that are slightly different. There are some rules about it. So when I take that piece of triangle and move it over here, and I make this rectangle, my base is right here. That's the base of this rectangle. My height is right here. We'll label that height. Not Bass. Height. Now, the reason this whole formula swap works is that if you look, when I take, whoop, don't want an extra arrow. When I take this triangle piece and put it back over and make it into a parallelogram again, if you look, the base and the height are the same. This base stayed the same, this distance stayed the same, and this distance stayed the same, whether I have the triangle piece here or over here. And that is why the same formula works for both. Now, there's one mistake that students often make, and it's this. When they look at a parallelogram, they're thinking about the height as from this tip down to this corner right here. They're thinking that this is the height of the parallelogram. You need to think of height as the distance from the base to the opposite side. So this line right here, the base is the distance from the base to the opposite side. That's the height, not this distance diagonally from corner to corner. That is not the height. And the reason we have to keep the height as this line from base to opposite side is what I just showed you, because then the base, or excuse me, the height stays the same when we make this into a rectangle. It's still this. So here are a couple parallelograms. I want you on a sheet of paper to pause this video, make a quick drawing of both of these, A and D, and then draw in a height line. Where would the height be? Draw the line in, and also label the base. So pause the video and draw in a height line and draw in a base. So label them both. Okay, so I'm going to draw in a base, or excuse me, a height line on this one, letter A. And it's right here. We don't need that yet. So this is our height line. And I'm going to say that it's 6 meters. And here, right here, is our baseline. And I'm going to say that it's 7 meters. And we're going to get to calculating the area in just a second. The height line on this parallelogram is here. It's from the base all the way to the opposite side. That's the distance. And we're going to call this one 13 meters. And we're going to have the base here be 4 meters. So now I'm going to actually calculate and show you how to do the area for A. So if we have a base of 7 meters and a height of 6 meters, then we multiply 7 times 6. 6 times 7 equals 42. We label it with meters, and we make sure that we're using square meters because we always measure area with squares. So our area for this parallelogram is 42 meters squared. Now you figured out the answer to D. Pause the video, find the area for parallelogram D, and then we'll check it. All right. So to find the area of parallelogram D, you had to do 4 times 13, because that's the base, times the height. And when I do that, I think 4 times 10 is 40. 4 times 3 is 12. So 40 plus 12 is 52. Our unit is meters squared. So 52 meters squared is the area of this parallelogram. All right, so that's the end of the video. If you didn't understand anything or didn't meet those two objectives, then you need to go back and watch again. Remember, if you're watching videos, you can always pause, rewind, do whatever you need to understand. We'll see you next time.